Hi everybody, thanks for coming. And this is like a rough hour, it's the end of the day, so first thing, thanks for being here. My name is Haggai, I'm a full stack developer. I was the first employee in a startup called Jaco, and today I work as a freelance in an educational tech company called Wiser. That's a little bit about myself. And today we're going to talk about ReasonReact and the language behind it, Reason. But before we dive in, let's understand our motivation. Why are we here in the first place? So suppose I want to build a React.js app today. One of the first things I'll probably need is Okay, something happened with the animation. I probably need some immutability, right? And I need it to be enforced. So I'll probably need a library called immutable.js. That's the most common used library today. And React is very declarative, and I'll probably want to chain function together. So I'll probably need another library. I can use Lodash, I can use Lambda. But the important things, I'll have to use something, a third-party library, right? And there's another thing, I'll probably need a type system because I want to avoid all those type checking stuff. I don't want runtime errors, and my wife is saying goodbye now. So I don't have it in JavaScript, right? I still need a third-party library. So I can choose today the most commonly used libraries are TypeScript and Flow. Okay. Now here's a question. What if we can have all those ability inherently, meaning it was part of the language? And we don't need to generate any code for that. It will be something that comes with the language. And this is what we're going to talk about today. So today we're going to talk about ReasonReact and the language behind it, Reason. And let's start with the question, what is ReasonReact? So the official definition is ReasonReact is a safer and simpler way to build React components using Reason. And in other words, the same guys who brought us React are now offering us a safer way to build a React app. And that sounds interesting so far, right? But we may ask ourselves, what is Reason? Because I haven't heard that name before. And the official definition again is a new syntax powered by the language OCaml. So first thing we need to understand that Reason is not a new language. It's just a new fancy way to write another language called OCaml. And it's just a different syntax for an existing language. So before we get any deeper, let's understand what Reason has. So it's immutable by nature. It's high performant in immutability. It has a really super fast building time. It's easy to write in a functional way because it has a special syntax for chaining function. And it has 100% system type, meaning that you have the guarantee that you won't have any runtime error concerning any incoherent types. And I mean about this sort of errors. Undefined is not a function. Like everybody gets those errors, right? So if you use Reason, it's guaranteed that you won't have any runtime error concerning types. But the next question is, like we said, so Reason is based on the ReasonML, but we may ask ourselves, why do we need even a new syntax? Like, let's just write it in a OCaml, right? And the idea behind it is to create you as a developer something that is familiar. You're probably all a web developer using JavaScript. So the guys at Facebook thought about let's make this similar. And if we compare between the two, they're not that different syntactically, I mean. I think that the only difference we can spot in this simple example is the array has a special pipelines, and you don't have to use return because every last line of function always states that this value will be returned. But you must agree it's quite familiar. So it's a good start for us as a developer to switch to something different and feel comfortable with it. Now, as I said, Reason compiles to JavaScript, and this is mainly thanks to the powerful compiler called BuckleScript. So, like I said, BuckleScript has a really fast build time. It's better than Babel. It's better than TypeScript around compilation time. It performs code elimination, meaning if you have dead code, it won't be part of your JavaScript output, and it optimizes your code. So your code will run faster after it's been built with BuckleScript. And the last thing, it also creates a really readable JavaScript output. Now there is another feature that BuckleScript contains, but we will get to it in a few slides. I won't forget about it, I promise. So, like I said, Reason is 100% type safe, and everything has to have a type. So, for example, if I combine two integers, I'll have to use the plus sign. But on the other, I have a bug here, so I don't know. You have to bear with me. But on the other end, if I'll add two numbers which are float, I have to use a different operator for that, and this is the plus dot sign. For string concatenation, I'll use the plus plus sign. So because everything has a type, we need different operators for that. And this concept will pay off in a few slides. So we made a really quick intro about the Reason language. Let's dive in and start building our first React component. Let's start with just a simple stateless component. First, let's remind ourselves how it would look like in a JavaScript way. We're going to create this greeting component, which outputs a div with the string oh hi prop name name. Prop name. That's a really convenient word. So if this oh hi sounds familiar to you, it's from this movie. If you haven't seen it, you must see it. It's one of my favorite movies. It's called The Room. This is my hello world. Like I'm obsessed with this oh hi mark. Okay, so this is the first time we're seeing a component in Reason. Let's go through it and see how it works. The first line, we defined what type of component is. In this case, it's a stateless component named greeting. The second line is the interesting one. We define a function called make. Make is the function we're gonna use when we want to render a component. And the first argument is the prop name it will get. In this case, it's a name. And in case we want to use children, we can use them. Because we're not using children in this function, we use the underlying score. And that's why you see this weird underline before the word children. Now, the second line, the line after that, you see the dot component. Can you guess what it is? You come from the JavaScript world. So I guess your intuition is probably right. We're spreading the component. So similar when we create a new object and we want to create a copy of it with an updated value, And this is the exact same thing we do here when creating a component. The component contains all the functions we need to create the component, and afterwards we only need to implement the one function we're actually using. In this case, it's going to be the render function. Now, as you can see, it's like regular JS6 syntax. It's also inherently part of the language, but different is we can't just type whatever we want. We have to say exactly what element we're using. In this case, we're outputting a ReasonReact string, and inside the string is the concatenation between our prop name and the static string. This is how we would use it. It's exactly the same way in JavaScript, but this is where the fun begins. So suppose we pass the wrong type. This is what we will get. We get an arrow saying where the problem was, what type it was supposed to be, and what type did we bring. So it's a very concise and accurate description on what we're doing wrong. And it's all happening in compile time. We don't have to run it to see the problem. Another good example of that is when we refactor a component, and after refactoring it, we're not using all the props. I guess it happens to you sometimes, right? But we're still passing those unused components to the refactor one. In this case, Reason will immediately yell at us that we're passing something that's not supposed to be there. So it's a really practical error, which helped me a lot. Another example of type checking. Can anybody spot what's wrong here? Exactly. And it's a very common mistake. And the compiler actually helps us autocorrect our spelling. And this is really cool feature I like. So all those examples I just showed you, they are officially supported inside any major IDE today. And immediately when you do any of the mistakes I showed you, it will syntax highlight them with accurate description when you hover them, and that's really, really useful. So let's talk a little bit type inference. So Reason has like really good type inference. Let's go over a simple example of how it works. In the beginning of the lecture, I showed you that every type has a special operator. In this case, we'll get the string op. The compiler will know which type his name is according to the string op. So we don't actually need to define what type name is. And that's one of the great things about type inference, that you don't have to define everything. The language knows by itself what the type should be. Okay, let's talk a little bit about CSS in JavaScript. So CSS in JavaScript has become really popular in the last year. We saw several libraries that gives you this ability. You got style component, you got Glamour, and ReasonReact also adopted this feature. So let's look at an example how this feature looks like. Suppose we want to style our div, and we can just use the React DOM style. We define what our CSS is, and we just pass it to our div. The main thing we get here, it's not just an inline CSS. We actually get the type safety. So for example, here, if you use the color twice, we'll get an error. And that's also just a built-in feature we get from using this CSS inside the Reason. Okay, Let's continue with our examples. Let's build a stateful component. So we're going to demonstrate a counter, and we're going to start with just plus and minus. And to do that, instead of defining a stateless component, we're going to define a reducer component. And in the React way, this is how the render would look like. Each click will get a different handle function. And in each implementation, we'll just update state. So far, so good. Okay, so ReasonReact took the design pattern of Redux and implemented the same pattern inside the component. In other words, instead of handling each event, we're just using we're dispatching an action, and those actions will be handled by the reducer. So instead of just using a handle x something, we're just using the send, and we passing what action we're actually trying to do. The reducer will use a switch statement to figure out what the appropriate state should be according to the action that it received. And you may, and again, everything has a type, so we probably might ask yourself, what is the type of action? So this brings us to one of the fundamentals data structure Reason has. It's called variants. And this is how a variant looks like. So the pipes are representing our statement. Let's start from the beginning. We have an action that can contain two values, increase or decrease. The OR statement, the pipe statement are OR statement, and the increase and decrease are the constructors. Now suppose we want to make it a little bit complicated than that. We want to define a dynamic value for each click. We can simply do that by binding each action with a value. In this case, we want to bind it with an integer. And this is how the dispatching would look like. So instead of just saying I want to send the action increase, I'm sending increase with a value. And when I want to actually extract this amount, I'll get it inside the switch statement. So there's something that's important to notice here. Amount is not part of the parameter reducer gets. It's actually being deconstructed from the action. And this gives us a very consistent signature that reducer gets, because some of the action might get a value and some get more than one value, and we don't want to change the reducer signature. So that way, each switch statement actually deconstructs the value it needs. So far, so good? Cool. Okay, so there's another thing I haven't told you yet about the switch statement. It's using one of the main feature in Reason. It's called pattern matching, and let's see what does it mean. So before we get to what pattern matching is, let's add another button to our application, a reset button. If we want to add the implementation for that, naturally we have to use the reset action. Now, in case we didn't implemented any update for that action, we will immediately get an error saying that we forgot to implement it. And this is a very, very important feature Reason has. Okay, so now we're getting to, I think, the most important part of this talk. And if you remember this point by the time you get home, I'm satisfied. Using pattern matching invariant is extremely powerful. Let me try to emphasize why is it so powerful. I just saw you a really simple example, but I'm saying it will make your life better. Okay, so let's use something a little bit more complicated. We previously used a switch statement for just one value. We can actually use switch statement on as many values we want. So let's use a switch statement that accepts two values. The first one is a Boolean. The second one is a variant called animal. And variant and animal can have three different values: dog, cat, and a bird. Cool. Let's try to calculate together how many combinations we have. So basically, we got a Boolean, it's two values, and we got three values for animal. 2 cross 3, I mean it's a 6th combination. And naturally, when we have to implement the switch statement, every possible combination has to be there. If we forgot any of the combination, immediately we'll get an error that we forgot to implement something. Now, why is this so effective? Now try to think about your day job. You're building an UI, and you need to take into account multiple views. You have async requests, you have loading state, you have complex form, you have user input, and you don't know what the exact order is, right? So when I'm building this type of logic, there's one question that I always keep in the back of my head, and the question is, what edge case am I missing? Like, I got all these states and the combination, and there's always a doubt that I forgot something. And this question always keeps bothering me when I'm refactoring someone else's code, right? Because I don't know if I understand the code completely, and because I get so paranoid, I have to write these extensive tests that make sure that I covered everything, and I have to keep them well maintained. Now we just looked at a simple example that contained just 6 combinations. Think about the real world. How many combinations you have to keep on the back of your head and make sure you cover them all. So Reason has a different philosophy. Instead of you take the responsibility, let the compiler do it for you. If you forgot something, he will tell you. It's like pair coding with someone that you really trust, that you won't make any mistakes. That's the power of pattern matching. That's what I think what got me really excited about building with Reason. Okay, so back to the first slide. We talked about what happens when we start our first app, right? And we always lean towards those 3 things. We want a type system, we want to write in a functional way, and we want immutability. So this is Jordan Walk. He's the creator of React, and I think it's taken in 2013 when React was first presented to the world. And there are a lot of interviews with Jordan asking him about the process of developing React. And when they asked him what language did he use to build it, he said he didn't use JavaScript. And naturally, it makes sense, because we saw all those things, immutability, functional programming, and type safety are not part of the language. So Jordan picked another language called SML, which is a cousin of OCaml/Reason. And SML is really similar features Reason has. So naturally, all the features Reason has, he had when he first thought about how Reason should look like. So what I'm saying is that React really wasn't meant for JavaScript, because we have to artificially create all those features. And actually, Reason is the way he was thinking about building it. It's more closer to what he thought about. But you may ask yourself, so why was it written in JavaScript? And the simple answer that you might have guessed is adoption. Like the guys at Facebook knew that if they want to get React popular, they have to release it to the most commonly used language, which is JavaScript. And their bet paid off. I mean, it's one of the most commonly used library for building UI today. So since then, JavaScript went a really long way, right? And today we can compile different languages into JavaScript. And this is the reason why we finally get to see Reason pops now, because the world of JavaScript really matured. So adoption is the same principle in Reason 2. And I'll try to explain what I mean by that. And so this is Jared Forrest. I hope I spelled his name correctly. And he gave a really great talk about the philosophy of Reason in the context of adoption. But I'll try to summarize some of the main points he talked about. So the first point we started talking about is the syntax, right? It's familiar. It looks like JavaScript. It helps developer get into it more quickly. The second thing, which is I think the most painful thing when you try to integrate something, integrate a new language, is I'll just explain it by like an imaginary example. So suppose you like next week go to your boss's office and you like giving the following statement. I found the most amazing language. It will solve us everything. We won't need any test anymore. The development will be better. We will need less QA. It's the most amazing thing in the world, right? You feel that the moment you try something at the weekend and you're really excited about it and you went to your boss and want to use it in production, and your boss would probably like, wow, this is amazing. Like, what do we need to do to integrate it, right? And that's the painful side. Like, we have to rebuild everything. That's because it doesn't play nice with our current core base. And this is the expression you will probably get from him, because he's a realist and he needs his product. You can shut down his product like for a couple of months, so you're probably going to stay doing it at the weekends and it's going to be your hobby. And the folks at Reason know this, right? Like, they know it from real experience and they want to make sure we will avoid it. So let's start what I mean by that. What do I mean by adoption? The first thing, I know I said that Reason is immutable. You can use mutation if you really need to. You can use it. There's a special syntax for that. But the most important feature I think there is the JavaScript Interop. And this is basically the ability to talk to your JavaScript code inside Reason. Let's just start with a really simple example. So we know this method, mathRandom, when we enter a console in Chrome or whatever. And let's try to import it into a Reason code. So to figure out what type the function, let's figure out like what type the random function is, what's its signature. We know it doesn't accept any arguments, and it returns a number between 0 and 1, right? So if a function doesn't have any argument, we call it in Reason unit. That's just a fancy name for that. And as we agreed, it's a float because it's a floating number between 0 and 1. Okay, so this had supposed to have animation, but bear with me. Let's go through it. On the most right corner, this is the name of the function that you want to import from JavaScript. The function signature is unit to float. Random is just an arbitrary name that we call our exported function, imported function, and we use this syntax called external with BS val. And BS is buckle script, just to, in case you're wondering what it is. Okay, so this JavaScript Interop is mainly thanks to the compiler buckle script. It wasn't, we wouldn't have this ability if it wasn't for buckle script. Another example of JavaScript Interop is when you switching to a new language and you used to implementing it in JavaScript, but you don't know how to make the translation and you're not sure you done it correctly. So you can use Interop again. And this is how it would look like. You can actually inline your JavaScript code inside the function, and it's cheating. Like there's no other word for that, but the main point, it will get your code going. You don't have to stop all things because you don't know how to implement something yet. After you finish, get things done, you can always return to it and re-implement it and make sure it works the right way. But what JavaScript Interop really means, it's giving you access to all the NPM models. So you don't need a special library for everything in Reason. You can use your, you can still have access to your old React component. And mainly, you don't have to rebuild everything. You just go component by component and rebuild it, go up the tree until you got all your component rewritten in Reason. But the main thing is that you do it gradually. You don't have to do it in one day and shut down your whole product. But, of course, JavaScript Interop has a price, because you're still running, there's still a chance now that you'll have a runtime error with types. You're injecting unsafe code into your system, so take it with a spoon of salt. Okay. Let's say, we're still talking about adoption. Let's say you just build a really cool library in Reason and you want to spread it to the world. And like other folks tell you, I don't use Reason, but I use Flow, and I want a type safety. So today you can use an existing definition of Flow and TypeScript, and they will convert it to types definition in Reason. But the near future, and this is what Jordan Walk is working right now, he just stated in his last interview, he's working about doing it the other way around, meaning you wrote your library, you can now export it, and everybody can use it, everybody can have their own type system, and it's safe to use. And this is part of the adoption, and it's really something I'm looking forward to. Okay. This is a very common question that is being asked. Is it production ready? So it's now being used in production by Facebook, and they converted most of their Messenger app to Reason, and they're really happy about it. Refactoring takes less time, less bugs. Build time is really fast. Like I said, all those features that I talked about in the beginning of the slides. But, and this is something that we need to remember, Reason is kind of new, and it has done some changes in the last year. So that's something we need to know about. There are going to be probably more changes. But I think what is the most important part is that the technology behind Reason is OCaml, and OCaml is a mature language. It's been existing for 20 years now. It's been used for Reason in the financial industry, and its type system is not going to change. And that's like the most important thing, because TypeScript and Flow change their type system several times. And this thing is rock solid. And that's something that you should keep in the back of your head. Okay, so this is really a basic schematic. Like, there's a lot of going behind it, but just to understand, we use bucklestrip to compile our Reason code to JavaScript. A cool feature that Reason has that it doesn't necessarily have to compile to JavaScript. It actually can compile to bytecode and assembler. In other words, you can create something in Reason, and it will compile to Android, Apple, whatever operating system you use, and even there's a really cool project that can output it to microcontrollers. Again, like, this is outside the ReasonReact. This is like just Reason. So if you're doing something like that, you probably have to switch libraries, but the language stayed the same. And there's a really, really popular library that uses WebGL, and people are developing a lot of cool games with it. So I think this was the most famous one that came out. This is by Jared Forestry, and it's a game called Graviton. He uses it in Reason. He's one of the main developers behind the library, and you can simply compile it to your Android, to your Apple, to Windows, whatever you like, and it works natively. But this is like another comment I usually get is like everything is switching to JavaScript, so it doesn't really matter if it compiles to native or not. And I disagree, because native code is still a lot faster than JavaScript. JavaScript has a really long way to get where native code performance-wise, and you can see it in React Native. There's a lot of blog posts comparing the different performances. So native is still here to stay, and Reason gives you this ability, which is really, really, really powerful. We talked about building a component with ReasonReact. We talked about the language, but let's just get the big picture here. If you start using now ReasonReact, you're actually learning a new language. And when you learn this new language, you'll be experienced with really, really good practices. Immutability, declarative code, pattern matching, type checking. These are really, really great features that will help you build a better code. So in a couple of weeks or couple of years, maybe you'll find yourself writing not React, but a game in Reason, a backend server in Reason, or I don't know, a program that runs on a microcontroller. I don't know, but the important thing that you still use the same language, and those patterns are the same. And I think this is what makes Reason really, really powerful. So I'll end with this note. Thank you for being here. I'll update this slide and give you extra links to extra material you can get to get started with Reason if that interests you. And I'll post it on my Twitter account. So thank you for being here. I hope you enjoyed.